So in this video, we're going to talk about how to describe the domain and range of functions using inequality, interval, and set notation. So remember that the domain is all possible x values of a function, and the range is all possible y values of a function. So we can describe domain and range using inequality, interval, and set builder notation. So if you need a review of this, please be sure to go back and watch the previous video, or you can refer to the study guide that's posted in your notes. So let's describe the domain and range of this function using inequality, interval, and set builder notation. So in all of these examples, I'm going to show you all three forms of notation, but on a quiz or a test question, you may only be asked to use one form. So let's start off with the domain. So let's look for the leftmost boundary of this function, which is here at -3. I have a closed circle, so that point is going to be included. The rightmost boundary is here at 5. And once again, I have a closed circle, so that point is going to be included. So my domain is going to go -3 less than or equal to x less than or equal to 5. Now the range is going to go lowest to highest. So the lowest point is here at -2, where I have a filled in circle. And the highest point is here at 7, where I have a filled in circle. So the range is going to go from -2, and that's less than or equal to y, to 7, which is also included. So remember, when I write these inequalities as intervals, I'm going to use square brackets because both of these endpoints are included. So this is going to be a square bracket at -3 and then another square bracket at 5. Similarly, when I write the range, I'm going to put a square bracket at -2 and another square bracket at 7. So in set builder notation, I'm going to specify which variable I'm talking about first. So this is going to be all x such that -3 less than or equal to x less than or equal to 5. The range is going to be all y such that -2 is less than or equal to y, which is less than or equal to 7. And so that's this function's domain and range in all three forms of notation. So now let's try this example. So I'm starting off with a domain, so I'm going to draw in my leftmost boundary. So that's here at -4, where I have a filled in circle. The rightmost boundary is here at 7, where I have an open circle. So the domain is going to be -4 less than or equal to x less than 7. The range is going to go low to high. So that's here at -3, where I have a filled in circle. And then the highest point is going to be at 9, where I have an open circle. So it's going to be -3 less than or equal to y less than 9. So now if I write these as intervals, for the domain I'm going to put a square bracket at 4, and I'm going to do an open parentheses at 7 because it's not included. And then in the range, I'm going to put a square bracket at -3, and then an open parentheses at 9. And then in set builder notation, this is going to be all x such that -4 is less than or equal to x, which is less than 7. The range is going to be all y such that -3 is less than or equal to y, which is less than 9. So now you can pause the video and try doing this problem on your own. So in this function, notice that the domain goes from -6 to +6. The -6 is not included. The +6 is included, so it's going to be -6 less than x less than or equal to 6. The range goes from -2 to 4. The -2 is included and the 4 is not included. So it's going to be -2 less than or equal to y, which is less than 4. So the -6 is going to have an open parentheses and the +6 will have a square bracket. The -2 is included, so that has a square bracket, and the 4 is not included, so I have an open parentheses. In set builder notation, the domain is going to be all x such that -6 is less than x, which is less than or equal to 6. And the range is going to be all y such that -2 is less than or equal to y, which is less than 4. So now let's try this example. So notice this is one of those problems where we have one endpoint, right? So the domain is going to start off here, right, at -7, and I have a filled in circle there, so that point is going to be included. Well, the rightmost boundary, it's just going to keep going to positive infinity, right, because this function is going to keep heading to the right. So the domain is going to go -7 less than or equal to x which is less than positive infinity. And the range now, well, I'm looking for the lowest point in my range, and there is no low point because the function just keeps going down. So it's going to go down to negative infinity, and then the top value is going to be 5, right? That's the highest point, so that's going to be included. So my range is going to be negative infinity less than y less than or equal to 5. So if I write these inequalities as intervals, I have a square bracket at negative 7. And remember, infinity always has an open parentheses with it. And then the range is going to go open parentheses at negative infinity, and then I'm going to have a square bracket at 5. In set builder notation, this domain is going to be all x such that x is greater than or equal to negative 7. The range is going to be all y such that y is less than or equal to 5. So now let's try this example. So I'm going to start off with a domain. So notice that this starts off here at negative 6, and I have an open circle at negative 6, so that's not going to be included. Then this function is going to keep going to the right, so the domain values are going to head to positive infinity. So I would write this as negative 6 less than x less than positive infinity. Now let's talk about the range. So the lowest point of this function is here at negative 4. And that curve just like passes through that point, so that's going to be included, right? I have no hole there. And then in the upper direction, well, it just keeps going up to positive infinity. So I'm going to say that the range goes from negative 4, and that's going to be less than or equal to y, and then it's going to head to positive infinity. So if I write these inequalities as intervals, I have open parentheses at negative 6 and another open parentheses at infinity. And then at negative 4, I have a square bracket because that point is included, and that goes to positive infinity, which is an open parentheses. In set builder notation, this is going to be all x such that x is greater than negative 6. And then the range is going to be all y such that y is greater than or equal to negative 4. So now you can pause the video and try doing this example on your own. So the domain of this function, well, it starts off at 4 and then includes all values that are greater than or equal to 4. So it's going to be 4 less than or equal to x less than infinity. The range starts off at 2 and then all includes values above 2. So it's going to be 2 less than or equal to y less than infinity. So if we write this as an interval, remember we need a square bracket at 4 because it's included, and then infinity gets the open parentheses. We need a square bracket at 2 because it is included, and then open parentheses at infinity. In set builder notation, this is all x such that x is greater than or equal to 4, and then it's all y such that y is greater than or equal to 2. So now this is one of those functions where we have arrows at both endpoints, right? So this is one of those functions that's going to go on forever. So let's start off by describing the domain. So the domain is going to go to positive infinity, and it's going to go to negative infinity. So when we describe the domain, we would say that it goes negative infinity less than x less than infinity. Well, now let's look at the range. In this direction, it's going to head to negative infinity, and then the upper boundary is going to be positive infinity. So it's going to be negative infinity less than y less than infinity. So as an interval, the domain is going to go from negative infinity to infinity. And remember, infinity always has open parentheses. And then the range is going to go negative infinity to positive infinity. Well, in set builder notation, let's think about what we're saying. If we're saying x goes from negative infinity to infinity, we're basically saying all real numbers, right? And remember, in set builder notation, how we describe all real numbers. We say that this is going to be all x such that x is an element of the set of real numbers. Okay, and so that's how we'd write that in set builder notation. Similarly with y, we would say this is all y such that y is an element of the set of real numbers. So now let's try describing the domain and range of this parabola. So the domain, well, we know for parabolas, they go to positive infinity and they go to negative infinity. So we're going to say the domain is once again negative infinity less than x less than infinity. Well, the range, well, we can see here in the lower direction it goes to negative infinity, But in the upward direction, we have a boundary right here, right? It stops at +4, which is included because we don't have a hole there. So the range is going to go -infinity less than y, which is less than or equal to 4. So if we describe these inequalities as intervals, we're going to say the domain goes from -infinity to +infinity. And we're going to say the range goes from -infinity to 4. And we're going to put a square bracket at 4, right? Because it's included. So in set builder notation, well, the domain is once again all real numbers, right? So we're going to say this is all x such that x is an element of real numbers. And then we're going to say the range is y such that y is less than or equal to 4. So now you can go ahead and pause the video and try doing this example on your own. So notice that this is an exponential function, so that'll help you figure out the range. So what happens in exponential functions is that all real numbers are included in x, so the domain is going to be -infinity to +infinity. The range, well, remember that exponential functions have an asymptote, right? So this one has an asymptote at y equals 0. So it's going to get really, really close to 0, but not actually equal it. So that's why we use the less than sign with 0, okay? So it's 0 less than y, which is less than infinity. So as an interval, this is going to go from -infinity to infinity, and in the range is going to go from 0 to +infinity. In set builder notation, x, remember, is all real numbers, so it's x such that x is an element of the set of real numbers, and then y such that y is greater than 0. So remember that you can describe the domain and range of functions using inequality, interval, and set builder notation. Make sure to pay attention to the endpoints of the functions you're describing and think about whether they are included or not.